Good day, everyone. So we have learned a lot of derivations and formula in this chapter. So let's connect all of them in one roadmap. First, we begin with the electric current that defined as the rate of flow of charge. And then the total charge Q can be defined as the number of electron multiplied the charge of electron. From here, we can express the I as NE, where the capital N here is referred to the rate of flow of electron. And then in the previous videos, I present how we can derive two equations from this diagram that we can have the electron density and also the drift velocity. Using these two equations, we can derive another formula for the current, which is I equal to NEF. And then we are introduced with one new term called the electron density that is defined as the ratio of the current to the area. And we can express J as NV. Next, we have talked about Ohm's law that given the formula of V equal to IR. And then we have proved the equivalence with the equations of J equal to sigma E. And then at the very early of this chapter, we learned about the mechanism of electric conduction, where when we have the battery connected to a conductor, we have a potential difference that produces electric field in the conductor. There's electrostatic force acted on the electron and cause the electron to accelerate. From here, we have derived another formula for drift velocity, which is expressed as EET over m. And then we combine these three formulas, and we can derive the formula of the conductivity equal to NE squared T over m. Please take note, there's two T here, which is on the top and at the bottom. So the T on top is referred to the time of current flow, while the time below refers to the time of collisions between the electron and the atom. Next, we're going to compare the conductivity and the resistivity, where the conductivity refers to the ability of the material to conduct electric current. And we have the equations of the sigma equal to NE squared T over m. Second is the resistivity that defined as the ability of the material to oppose the electric current. And we have learned the formula of the resistivity equal to RA over the length of conductor. So based on definitions, we have the relationship of the conductivity is the reciprocal of resistivity. With this, we can derive another formula for the conductivity and the resistivity, that the conductivity is the reciprocal of resistivity that equal to the length divided by RA, whereas the resistivity is the reciprocal of conductivity, and we can express the resistivity as m over NE squared T. So these are the roadmap for the electric current. There's a lot of terms and also the connection of the formulas. So please do revisions on the derivations so you can master this topic very well. So that's all for the roadmap today. So you can leave a like and share the video if you think this video is useful. So I'll see you in my next video. Thank you.